Okay then, we are now looking at C2a, and we're starting off by looking at the structure of the Earth. You'll see over on the right hand side there's a diagram there, and you would be expected to know all of the different parts of the Earth. On the outside you have the crust, which is rocky and thin compared with the other layers. Then you have the orangey section, which is the mantle, and then the inside you've got the outer core, which is liquid, and an inner core, which is solid. The core contains the iron and is very hot. If we looked at plate tectonics, for instance, if we take together the crust and the outer parts of the mantle, these are called the lithosphere. It's the crust and the outer mantle, and the top is cracked into these tectonic plates. This is rigid and relatively cold. It's broken up into huge parts, and these tectonic plates are less dense than the mantle, so they can float on top of it. It's a little bit like having a sort of bag of jelly, if you like, with a plate on the top, and it'll sort of move along. The tectonic plates move very slowly. They probably move as much as your fingernail grows in a year, so you can see it's a small amount. Earthquakes happen because the movement of the tectonic plates, the volcanic activity happens where the plates meet. The molten rock or magma gets to the surface through the weak spots in the crust, and the magma then rises through the crust because it's less dense than the actual crust itself. Okay, so as I said, there's a structure of the Earth, and you should be able to label all of the different parts of the Earth. Now, this plate tectonics was brought about using a theory by a German scientist called Alfred Wegener, who published his theory about continental drift in 1914. He noticed that the shapes of the continents fitted together, and I'm sure if any of you have seen Ice Age continental drift, you'll see what I'm talking about. He suggested that the continents were all once joined together, then gradually moved apart. Unfortunately, he was unable to explain how the continents could move, and he was not a geologist, so his theory was not believed, like most scientific theories, until the 1960s, when advances in science began to show how the continents moved. Scientists discovered convection currents in the mantle, and they discovered evidence that tectonic plates were moving apart under the Atlantic Ocean, leading to sea floor spreading, and they discovered something called subduction. Now, subduction is when the oceanic plates collides into continental plates and dip down as it has a higher density. And this diagram here shows you exactly what's going on, and again you may well be asked to talk about subduction and talk about the lithosphere sliding underneath the other plate. Just in case you're asked, please don't forget there's the three types of rocks. You've got your igneous rocks, which come from the molten rock cooling down. And remember as well, if you have larger crystals, and some examples of igneous rocks are granite and basalt, and if you have larger crystals, this is because the rock has cooled down quite slowly, and it's given the crystals a chance to form. So you may be asked to say, if something's got smaller crystals, how fast did it cool down? And you can say, well, it must have cooled down really quickly. Okay, and that is the end of C2a.